We're going for a ride in the turbo car.
This is a motor out of my 1973 Ford Thunderbird. I'm disassembling it due to a really harsh misfire after I was doing a pull and it backfired during the pull and started missing really bad on a couple of cylinders. When I went to inspect the plugs, 2 of the spark plugs had been smashed by material or debris that went through the cylinder. I didn't have an inspection camera, so I couldn't look inside the motor. So I pulled it out, just doing a disassembly on it, see what the hell broke. It didn't seem to bend any push rods, no valve train was messed up. Everything, when you had the valve covers off, rotated the motor, looked just fine. It didn't make any odd noise, but when I tried to put a different plug back in it, it still misfired like hell. Something was up. I believe one cylinder was down on compression. It sounded weak on one cylinder. So I'm going to let this video play through until I get the video will slow down, and I'll explain once we get to see some of the carnage. Most of the parts on the motor, exterior drive parts and brackets and such, are all powder coated along with the intake manifold. One of my good neighbors does powder coating, does a real good job at it. But the block and the cylinder heads are just spray paint. And these are the stock iron cylinder heads. They're quite heavy. I did do some minor porting on them on the exhaust side mostly, just smooth the intake side up, but the exhaust, it was pretty restrictive, so I did some considerable amount of porting on the exhaust ports to get some flow on these heads. They seem to flow pretty good. They're not the early model cylinder heads, the pre-70s that had higher compression. They're lower compression heads. I think they're 87 or 90 cc combustion chambers. And here we go, we get to see this one piston on the back right there. It has a chunk missing from it. Pretty good section. This happened to me before and I thought it was ring end gap that caused this failure, and I don't believe it was ring end gap. I believe I had the timing a little too far advanced, and pre-detonation beat the piston into braking. I have no knock sensors or anything. This is an old school setup. I run a blow-through carburetor with a cheap eBay style GT45 turbo. It has a ported back housing, so it flows a little bit better, and a billet wheel on the front. We're only making about, I want to say in between 8 and 10 pounds of boost. It's pretty small wastegate on it, so in top gear it gets a little bit of boost creep, runs up to about 10 pounds, but down in the lower gears it's about 6 to 8 pounds of boost. Still makes pretty significant power at that. In a minute here I'll rotate the motor over and we'll get to see if it damaged the bore or not. The last motor I had that did this to me, it cracked the block. A little better look at the broken piston. The motor is a pretty clean engine. The motor wasn't in the car for very long before this failure happened, so everything's fairly clean. You can see the ring end gap right there isn't narrow. I don't believe it was the ring that did this. I would assume if the ring end gap is what caused the failure, the ring would also be bent in an upwards position. And it seems like all the parts, they blew out the exhaust. They luckily didn't get into the turbo. They were pretty heavy, so they stayed down low in the exhaust system. They didn't get pushed up into the turbo. As soon as I heard the backfire, I shut the motor down. I think I got pretty lucky. All the other pistons look good though. And the piston that failed was the same one that I had fail on a previous motor too. The same side, same hole. There's not much I can do to change. I can't adjust timing individually by cylinder. It's just overall. I have the distributor locked out. I set it at about 28 degrees total timing, and I have a BTM box, the boost timing retard box. It'll pull 1 to 3 degrees of timing per pound of boost. I believe when I was running this, I had it set at about 1. So it wasn't pulling too much timing. I might have had it set a little lower, maybe in between 1 and 0, maybe half a degree per pound of boost, which is probably why I seen this failure. It's running pump gas, no special gas, no E85 or anything, just 91. And here shows the heads. Only the one cylinder showed damage, even though we had multiple misfires. It didn't damage the valves. The valves weren't bent. But I'm going to go ahead and replace the valves anyway. I have extras laying around. They're used, but they're clean. And I'll just do a simple valve lap on it and clean up the surfaces and put everything back together with a new set of pistons, it looks like. I haven't found anything else yet that's that bad. But pretty soon here I'll flip the motor over and we'll pull all the rest of the pistons and rods. We'll check out the bearing condition and everything. This is the model of the cylinder head. It's a D3VE-A2A, which is a passenger car 4-barrel carburetor model cylinder head, right at the turn of the smog era. So the only type of smog it has is one crossover port on one of the 4 cylinders that cut through the intake manifold, which I have welded shut. I put a steel plate in and had welded those areas closed. That way they're not soaking the intake manifold in heat. And the motor still spins over pretty nicely. Cam is in good condition. Lifters and all that stuff are really clean still. They don't have that many miles on them, but they look pretty nice. So I'll be reusing all this. I kept it all in order, that way it'll all get put back exactly the same. The only thing that seems to be needed to be changed right now is pistons so far, but if it's coming apart, we're going to end up putting rod and main bearings in it too. It's a pretty simple job. Now I'm just looking around to see if I notice anything else that's out of the ordinary. In a minute here we'll put the camera back up on the stand and start the time lapse. And it's I can't remember what brand oil pan. It's got baffles, crank scraper, and hinged gates in it for better oiling. I do use this car for drifting, and I would get bad oil pressures when sliding for one direction for too long, as in hitting a donut box or doing circles for a long period of time. The oil pan seemed to fix that. And here's the piston. It's got a crack right above the pin boss, right below the oil rings on one side. Then on the other side, it's cracked all the way across the pin boss connecting area. Also, the rod and piston, as you can see, are pretty stiff. They still move, but not very easily. You got to put some force behind it. Bearings are a little rough on this one. On this piston, there was no marks that you could feel in the bearing journal with your fingernail. It'd just look like it had some decent amount of wear on it. Here we'll get to take a look at what the cylinder looks like. Make sure the cylinder's not too damaged. This will determine if I need a new block or not. Sadly, I did try to record when I was doing this, but when I switched the GoPro from time-lapse to a standard video, it wasn't recording audio. I didn't notice this until after I had uploaded the video and watched it. Do a quick cleanup before I start the rest of the disassembly, pulling the rest of the pistons and rods out. Now that we got all the pistons and everything out of the block, we can take a look at the condition of the crank journals and what all the cylinders look like. I'm assuming it hasn't changed much, being that this only had basically a couple of miles on it. It didn't last very long. It looks like ring wash, too much fuel, causing a weird wear pattern on the side of the cylinder there, because that piston had nothing wrong with it. I see it in a couple of the holes. I was running my air fuels somewhere around 11.5 to 12.5, but you know, sometimes you can't control it. It dips a little bit low. I'd rather lean on the rich side than the lean side. And right here we see whoever assembled the motor beforehand must have nicked the journal right there, or the rod, or the main, and with the bolt coming off of the rod, because it has a small mark in it. And then we see what that small mark did to the bearing. I think it was piston number 6 it did this to. And it dug a pretty good groove through the center of that bearing. Luckily, it's not a very big mark. I'll be able to take a small diamond file, knock the ridge down, and then polish the area, and it should run just fine with a new set of bearings. We're not looking to get a lot of miles out of this motor, we're just looking to have some fun with it for a little bit of time. That seems like it. We found the issue. It's got a broken piston, and it's got one bad rod bearing due to a mark in the journal. We'll go ahead and polish it up. We'll clean up the motor, get a new set of pistons. We're probably going to put a set of flat top Speed Pro pistons in it.